NASA says we're completely safe, but right now, a 1,100-foot wide rock named Apophis is hurtling through the dark, headed straight for our neighborhood. This vector graphic shows exactly what that near miss looks like. Here is Earth, surrounded by the geostationary ring, where your GPS, weather, and television satellites operate. In April 2029, Apophis will slice right inside that ring. And as we zoom in on that trajectory path, you can see a tiny 600-meter window floating in the vacuum. Astrophysicists call this a gravity keyhole. If the asteroid misses that invisible window, it safely sails past us. But if it passes exactly through that microscopic gap, Earth's own gravitational pull redirects the rock, turning a harmless flyby into a mathematically guaranteed collision on its next orbit. We have tested ways to stop an impact before. In 2022, NASA's DART mission slammed a kinetic probe into a small asteroid and successfully altered its orbit. But Apophis might be built entirely differently. Current observations suggest it could be a rubble pile, a loose collection of scattered boulders, rock, and dust held together only by its own weak internal gravity. This comparative visualization illustrates the physical dilemma. On the left, a solid rock gets neatly pushed off course, but on the right, kinetic force applied to a rubble pile simply shatters it, turning a single bullet into a shotgun blast of debris. If you try to ram it, you don't move it, you just scatter it. Our proven planetary defense models break down entirely against an object that refuses to hold its shape. So what happens if our math is wrong? We have to run a red team simulation. What follows is not a prediction of the future, but a strict physics-based projection. Phase 1 begins on April 13, 2029. Apophis makes its approach, but an invisible meter-level deviation in its path pushes it straight into that 600-meter gravity keyhole. This diagram maps the immediate aftermath. The asteroid's orbital line bends sharply around Earth's gravity well, slingshotting outward into a wider loop. Watch as the simulation fast-forwards. The altered loop tightens. Years later, the rock returns, intersecting dead center with Earth. The disaster doesn't start with a fireball in the sky. It is mathematically sealed during a completely silent, invisible pass millions of miles away, years before anyone even looks up. Phase 3 is the return. A 1,100-foot mass violently tears through the upper atmosphere at tens of thousands of kilometers per hour. The kinetic energy released upon impact would exceed 1,000 megatons of TNT. That's roughly 20 times the explosive yield of the largest nuclear weapon ever detonated. Based on current orbital models, a localized strike of this magnitude could center on densely populated economic zones. If it hits the shallow waters of the North Sea or the Black Sea, massive walls of water would immediately radiate outward, swallowing coastlines. Humanity survives the initial hit, but the instant destruction of critical shipping infrastructure, international ports, and global supply chains in those specific zones would trigger a total systemic breakdown of modern global commerce. But a physical impact introduces a secondary problem, the human variable. If Apophis hits the keyhole in 2029, we would have years to wait for the return impact. Global governments would face an immediate dilemma. Do they release the orbital math and risk instant worldwide panic? Or do they withhold the data to maintain civil order while scrambling for a deflection strategy? We have a long record of facing anxiety about the sky. Historically, we explained comets or rogue asteroids as omens. Texts like Revelation describe a falling star named Wormwood, turning waters bitter. For centuries, humans framed these distant cosmic events as divine judgment. Our ancestors dealt with myths, but a modern keyhole breach forces civilization to stare down a cold, verifiable mathematical certainty. Waiting for a disaster when you know the exact day it arrives is a far heavier psychological burden. Let's step completely out of the simulation. Based on the hard data we have right now, Apophis poses zero threat to Earth for at least the next 100 years, but the solar system is a vast mechanism of time and gravity. A physical deviation of just a few meters today compounds into a trajectory shift of millions of miles over decades. So if astrophysicists ever do detect a rock locked into a true, unavoidable impact trajectory, would you actually want them to tell you? The real danger out there is the terrifying fragility of the formulas keeping us safe, and the tiny margins floating in the dark between a harmless flyby and a direct hit.